Now we'll see about missing values. In data collection, in any company that is working with data, there is a task to handle these missing values. So what are these missing values? Missing values, as the term indicates, the values are missing from the data itself. And to handle what you are going to do with these missing values is an important business decision, as this will affect your insights derived from the data. Now, here in R programming, missing values are denoted by NA or NaN, which means not a number, for undefined mathematical operations. Now, there is a function called is.na which can be used to test objects if they are na, which means the values are missing. And the same thing for is.nan. So na values, they also have a class. So there can be either integer na, character na, etc. A nan value is also na, but the converse is not true, which means a nan value can be na, but na cannot be, might not be possibly nan. Now we'll go with the next thing. There is a vector defined here which has the values 1, 2, na, 10, 3. So now let's check with this example. X contains a vector 1, 2, 3, na, 4, 5, 6. Now the vector is created. Now if I want to check whether this vector contains na values, I can use this is.na function, which will display the logical values for the x vector. Now it is false, 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 true, which indicates that there is a missing value inside this. Now the same way you can use is.nan. Here in this example you can clearly see that it shows false, false, true, true and false for nan as well as na. But here if you see, here it is showing false, 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 false and false, which indicates that nan will not be able to identify na, but na will be able to identify nan. So that's the difference between not a number and na. Now we'll move on to data frames. Data frames are used to store tabular data. So when you have a table of values which contains multiple columns and you want to add it into the data set of R, the object that you have to use is data frames. These are represented as a special type of list where every element of the list has to have the same length. As we saw earlier, a list is a set of vectors which will have different class of objects, but here a data frame is a special type of list. Every element of the list has to have the same length. Now a list will correspond to a particular column in a table. Imagine a table side by side with this data frame, and the data frame will have a particular list of elements, and each element will correspond to the columns in the table. Unlike matrices, data frames can store different classes of objects in each column. Matrices must have every element to be in the same class. Data frames also have a special attribute called row.names, and they are usually created by calling read.table or read.csv. You can either read it from a table or use a CSV file, or which is actually an Excel file stored in CSV format, and you can read it from there. Or you can convert it to a matrix by calling data.matrix. Now there are two elements in X, the data frame X. I'll show you an example. Here the first element is called FOO and the next element is called bar. The first element is a list with integers 1 to 4 and the next element is a vector with logical values. Now the number of rows is 4, the number of columns is 2. The number of columns shows you the number of elements in that list. Now we will move on to the names. Any object in R can have names. This is useful when you want to write a code and which will have self-describing objects. When someone else views this code, they will also be able to get a good sense of what's happening in the code. Now let's say I create a vector. I create an integer sequence with 1, 2, 3 values. Now using this names of X function will give me if there are any names predefined for 1, 2 and 3. Now as there are no names defined, it will leave me with null. Now if I want to add names to that, you can add it by using names of X. This names of X will be a vector which will be assigned to the values 1, 2 and 3. Now let's say I want to divide by A, B and C. Now the names have been assigned. Now if I see names of X, you will get A, B and C, and the values of X are 1, 2 and 3. For 1, 2 and 3 you have assigned names A, B and C. Now again, as I said earlier, any object can have names. So do lists. So let's say there is a list which contains values A, B and C, values 1, 2 and 3. Each are assigned a name A, B and C. Now it is named. The value 1 is corresponding to A. This kind of naming will help you retrieve the data also from the list created. Again, names in terms of lists and objects, you can also use it for matrices. let's say there is a 1 cross 4 matrix and the number of rows is 2 and columns is 2. You can add using dim names of m. We'll do that in the console. Let's create a matrix which contains values 1 to 4 and number of rows is 2 comma number of columns is 2. When you display the matrix, you will see 1 2 3 4 added to it. And if you want to add the names A B C D to each of the rows and columns, what you can do is dim names of m. M denotes the matrix here, and you want to add a list of vectors which will be the names of the matrix. Now I'm trying to assign. As you can see, the dimensions have changed from 1 to 1 to 2, A, B and C, D. A denotes the first row, B denotes the second row, C denotes the first column, D denotes the second column. Now this is how you create names for matrices. These are very useful when you want to access certain values of the matrices using just names.